Assalamualaikum. My name is Dian Fitritasari binti M. Jamil. I would like to present the project-based learning of quality assurance and quality control. So, our title is the control variable chart for the Jack and Jill peanut nibs. So, we go through to the S chart. What is X chart? S chart is used to monitor the mean of the process based on 20 different pack of the nibs peanut, nibs chocolate. So, how? So first, we have to find the mean of the sample. So we will take 20 sample of the nibs chocolate and replicate the length of the peanut. So in order to find the mean, so we will sum up all the length of the peanut 1, peanut 2, peanut 3, peanut 4 and peanut 5, and we divide by the number of the peanut, which is 5. So we will get the mean. So how about the double X bar? Double X bar is by the formula is the total of the mean divided by the total of the sample. So from here we can see that the total of the mean is 32.670 cm and the total of the sample is 20. So we will get the 1.634 cm for the X double bar. Next, so, next we want to know about the CL, UCL and LCL. What is this? The CL is a control limit. This is a natural process of the limit, which is our mean. UCL is upper control limit and LCL is lower control limit. So these two is form a range within which the nib chocolate meet the quality criteria, which is the length that we measured, is at the expected value. So this is the formula for the upper control limit, which is x bar plus a square r. So the uh, the UCL we will get is 1.849 cm, while for the lower control limit, the formula is x bar minus a square r, and we will get 1.419 cm. And the a square is we get from the control chart. So from here we have we calculate 5 subgroup. So we get the a square from this control chart. Okay, next. After we get the UCL, CL and LCL, so we can plot a graph. So from here we can see that the there are two subgroup that exceed the lower control limit, which is subgroup 2 and subgroup 6, and the mean is the same, which is at 1.360 cm. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Is Atifana binti Ismail. We continue my part, which is the new X bar chart. So, from the previous calculation in the X bar chart, sample 2 and 6 have mean value which is 1.36. This value is exceed the lower control limit. This can shown in this graph where we can see this sample 2 and sample 6 have exceed the lower control limit. So, we need to find the new X bar chart by removing these two samples. The first step that we have to do is to find the new X double bar to X double bar. To find this value, the formula we use is the total sum of the X bar will minus by the number of the X bar value for the sample that we want to remove, divide by the total sample minus with the total sample that we remove. So the total sum of the X bar we use is that we get is 32.67 minus by the X bar value for the sample 2 and 6, which is 1.36, divide by the 18, because we remove 2 of sample from the total sample, and we will get is 1.664 cm. The next step is we find the UCL and LCL. To find the UCL, we use the formula S bar naught plus with A sigma naught. While for the LCL, we use the formula S bar naught minus A sigma naught. S bar naught equals to the X double bar new value, which is equal to 1.664 cm. And for the sigma naught, we can find from the formula, which is R naught divided by D2. R naught we can find from the calculation. From D2 and A, which are the constant control factor, the value can get from this table, which the subgroup size of this project we use is 5. So the value for D2 is 2.326 and for the A is 1.342. So we insert this value in the formula of the UCL and LCL. So this is the new S-bar chart that we get. As you can see, the orange line is the new UCL, which we get is 1.867 cm, which is higher than the original UCL. While for the lower control limit, the new lower control limit value that we get is 1.461 cm, which is also higher than the original one. So, here I conclude my presentation. Thank you very much.
Good day to Dr. Rosniza and fellow friends. My name is Shani Dr. Lincoln, and today I am going to explain the R chart of NIPS chocolate sample. Basically, this analysis is done using 20 samples of NIPS chocolate and 5 replicates is made from each sample. In this analysis, the R chart is used to evaluate the variability of the manufacturing process based on the length of NIPS chocolate taken from 20 different packets. Basically, the control limit will be used to track the variance of the manufacturing process. There are 3 types of control limit, which is the upper control limit, and lower control limit. The control limit is the natural process limit, while the upper control limit to the lower control limit to the upper control limit form a range within which the NIPS chocolate meets the quality criteria, which is the length, expected value, or a normal deviation. In this analysis, the quality criteria that we are measuring is the length of NIPS chocolate. So the X bar value and R bar value is tabulated in the table. The R value is highlighted in green, as we can see in the slide. So the sigma R can be obtained by totaling up all the R value for each sample, in which we get 7.46. The R bar value can be obtained by dividing the sigma R value with the number of sample M. So in this, we divided 7.46 to 20 and we get 0.373 cm. This is the control limit value also, which is 0.373 cm. The upper control limit can be obtained using the formula D4 times R bar, and the D4 value can be obtained from the figure 1.1, which is located in the next slide. So in this analysis, the UCL value obtained is the 0.789 cm. The lower control limit value, which is the LCL value, can be obtained using the formula D3 times R bar, in which we get 0 cm. The D3 value also can be obtained from the figure 1.1 in the next slide. This is the figure 1.1 mentioned earlier, which can be seen to determine the D3 and D4 value. It can be determined by looking at the N value, which is the subgroup value, and the N value of our analysis is 5. So the D3 and D4 value can be obtained, which is the D3 value is 0 and D4 value is 2.114. This is the R chart value for the sample of NIPS chocolate. As we can see, the upper control limit value of our analysis is the 0.789 cm. There's only one subgroup, which is subgroup 8, exceeded the upper control limit, which is 0.80 cm. The other value is in the range of the lower control limit and upper control limit. Thank you. That's all from me.
A very good day to my lecturer. My name is Zhao Zixiang. So today I'm going to present about the new R chart. I will continue present with the new R chart. So first of all, so this table here, as you can see here, is the sample table. So in the previous calculation, we calculate that in sample 8, we have a R value of 0.8. Here you can see in the slide here, which is it exceeds the upper control limit of the original R chart. So now we need to remove this sample here because it exceeded the upper control limit of the sample. So we formulate a new R chart. So how? So the step. So first of all, we must find a new R chart. So this is the formula by using the total R minus the R from the sample 8 So and the sample value is become 19 because we remove the sample 8 from the chart. So these are new R. So later we need to find our new upper control limit and lower control limit. So here are the formula you can see here, d2 and times sigma naught. So the sigma naught is a bit out of line because of the technical issue here. So it should be in the same line as d2. So these are the formula. So where do we get the d2, d1 and the sigma naught? So the sigma naught we get from R naught over d2. R naught is from the new R. You can see it's the same value here. And d2 we get from a constant from a table. As you can see here, where d2 and d1 are constant control factor. So this control factor is constant. We get it from the table. So by looking at the table, we choose the n which equal to 5. So we get the d constant value there. So now we have the new upper control limit and the new lower control limit for the R chart. So now we'll be plotting a new graph. So this is our new R chart graph. Actually this is the original one but the line, the red dotted line here signify the new control limit So you can see here the dotted line indicate the new upper control limit, which is equal to 0.474, whereas the lower control limit here is still the same, equal to 0, same as the original, no much change for here. So you can see compared to the original one, it's being lowered a bit after this sample is being removed, so it will be lower a bit. Alright, so here I conclude my presentation. That's all I have. So I thank you for your patience and listening to our presentation. Thank you.